Okay, I hope everyone can see the slides right now. Is this slide is referred to a capacitance. Okay, what they mean with the capacitance? Okay, capacitor or we call as capacitor. Okay, when they have the S, it means we have more than one. That's the reason they put as a S. So most of the thing in this chapter we will learn based on the capacitors. So capacitors means it's one of the component. Okay, example based on your resistor, based on the inductor. Okay, it's also one of the components based on which we call as a capacitor. Okay, so what they mean with the capacitor? Let's go with the next slides here. Okay, just have a look on the pictures there at the side here. Okay, based on the figure here, what's the component is it? Okay, these components are related to your capacitor. So just have a look on the diagram. Just have a look on the diagram. So you can see many shapes of the capacitors here right now. Okay, so one of the part they call as a semiconductor. Okay, semiconductor capacitor. Usually when they say semiconductor capacitor, it will be look like in this form. Okay, example like a circle shapes here. Okay, and also one of the part you can see they call as a ceramic capacitor. Ceramic capacitor means this one. Okay, they have a difference between these two, but both of the functions we defined it as a capacitor. We say store energy. All right, and you can see this type of capacitor too. Okay, and okay, most of the thing, what the difference between a ceramic capacitor with a semiconductor capacitor? They have a few things different because when they say ceramic capacitor, this one, example, this one or this one, okay, the value of the capacitor will be too small or they were going to say only 1 microcapacitor, okay. The unit we're using for capacitor, sometimes they highlighted 1 microfarad, okay. They use the word, the alphabet F. So F means stand for farad, okay, the unit we measured is based on the farad. Okay, so at the same time if we do some circuit, okay, we also can have a capacitor in the symbols of this shape. Okay, at the same time we also can have a capacitor in this shape. Okay, so one is a straight line, one you can see like a curve. All right, and you may have a look on the A1. Okay, this I just wrote as a A. Okay, I write this one B. So in the A, you can see they only shows you in terms of the straight line. Okay, they don't shows you any curve. All right, have a look on the B. So in the B, these are symbols of capacitor, and one side they shows you one of the terminal is just a straight line, and the next terminal they shows you like a curve. Okay, they will have in this. Okay, all right, and this is a one more terminal side. Again, why we should have the A and why we should have the B? Okay, usually for the A we always say it's a ceramic capacitor. It means this type of capacitor. We don't have as they won't going to highlight the polarity positive and minus, but usually they will say this is a positive part, this is a negative part, the polarity. But when it's come to your B, you need to define the right one based on the positive with the negative part. So this one always refer to the semiconductor capacitor. It means this one. Okay, so when you have a look on this type of semiconductor, they always write a value. Okay, the value of the capacitor at the side. Okay, is it okay? Example. I hope you can see. Okay, later on you can zoom based on the slide. Okay, in my view, I can say it's a 4,700 microfarad. Okay, so this the measurements value they measured for this capacitor value. Okay, at the same time they also have the polarity. Okay, example when you study about LED. Okay, in case in LED we call it as a light emitting LED. Okay, this is the one LED. So from this one, okay, we always have the cathode and anode. What mean cathode with the anode means we have the polarity of a positive and negative. Okay, it's the same goes to your capacitance. Okay, for the semiconductor, they always have the long terminal, they always have the short terminal. Okay, so take note about this part here. If they say semiconductor capacitor, how you going to differentiate based on the symbol? They always have the plus and minus. At the same time, the we have here one terminal will have a long leg. Okay, what I means this terminal will be long and one more terminal will be short. So that's the way you're going to identify which one is a cathode, which one is a anode. So later on you will know. Okay, and what the purpose? Okay, sometimes Miss can ask you what the purpose of capacitor, or sometimes I will ask what the definitions of the capacitor, or sometimes I can ask you what the functions of the capacitor. Okay, or I can say I can ask you how is it capacitor works in the circuit. So most of the common things or the key point that you need to know based on the capacitor, take note. they always store energy, or we say electrical energy. Okay, so we use the word discharge with the charge. Okay, take note, we use the word charge. Okay, this is charge, discharge, and one we use the terms of charge. And how they related is the store electrical energy. So that's the functions of the capacitor. At the same time, the components of capacitor we also say as a passive electron components. Okay, when I say passive electronic components means they also can be in a resistor, they also can be inductor, they also can be capacitor. But most of the common things for the capacitor we always say is a passive electronic components. Okay, which we have two terminals. So when they say two terminals means, example, the two leg. So this is the one means always say as a leg, but the proper terms that you need to use is terminal. This one, the silver line, you can have a look here, the silver line. So that's the one we call as a terminal. Okay. So let's go with the next part. Okay, this is just a learning outcome. What you're going to do is the same thing related to your electric field. Okay, it's related to the components. Let's go for the next part. Okay, this is the term that you need to understand based on the capacitor. Okay, capacitor, the key point. Okay, maybe you can have in your quizzes later on. Okay, so it's based, we have based on the charge, based on the capacitor, and also we have capacitance. Okay, capacitor with the capacitance. Later on, you know what's the difference they mean here. And the next one, they have the dielectric strength. Okay, if you see the word dielectric strength, which we have in the last class, we also did for the electric strength, but we use the based on the we use the terms of electric field strength. Okay, but in capacitance, we using dielectric strength. Okay, and the next part is based on the energy store. Okay, and the next one is based on the potential differences. So when I go through or misread based on the potential differences, you need to know it stand for the voltage. So voltage means it's related to your supply. Okay, this is the one they call as a potential differences. Even though when they are having based on the capacitance, the components, okay, it means the supply. Okay, let's go for the next part. Okay, overall of the chapter. Okay, based on this capacitance chapter, I think capacitance also is not a long chapter. They're always in the short. Okay, I mean the information for the capacitance. Okay, so the first one, they have a parallel plate capacitor. Just have a look. The overview means the contents that we have on the slide, this slide. Okay, so we have based on the parallel plate capacitor. The next one is based on capacitance, and the third one is a factor. Okay, factor means the parameters which affecting the capacitance. Okay, example, we say when they highlighted to you the word factor, okay, or they say the word parameters, it means in which parameters, which parameter will be affected the capacitance value. Okay, example, we say the capacitance or the capacitor's value is 50 microfarad. Okay, but due of some term, due of some parameters, okay, they're going to affect the value of the capacitor. So this is the main thing that you need to know, what the factor affecting the capacitance. Okay, sometimes we can say the heat. Okay, the heat of the currents flow into the components. Okay, sometimes the environments of the which conducting based on the measurements value. Okay, so they have a few factors that you need to know. Okay, and the next one, the last one, the fourth one here, is based on the capacitance in series, in a parallel, and also series parallel, and also energy store. Okay, so what they mean with the series parallel means is the form, how they build up the circuit. Okay, take note, Miss repeat back. Capacitance, what they mean with series parallel. Okay, sometimes they also using the word shunt. Okay, shunt is same thing. Okay, I mean can conclude. Okay, we can also say the shunt as a parallel. Okay, series means all your connections, okay, with the components will be in the straight line. Okay, example, I say you have a capacitance here, you have a capacitance here, you have A, you have a B, you have the C. So this line, all your terminals, okay, based on your capacitance will be jointed in the same connection, okay, in the straight line. Unless they highlighted to you parallel, or they use the word shunt, S-H-U-N-T, shunt, it means they're going to have the capacitance in the opposite direction. So it means they're going to arrange the capacitor in the opposite direction. So what I mean with the opposite, it means you have the capacitance A. After that, you have one more capacitance at the opposite. So this one means just say as the opposite. Okay. And the next one, you have the next capacitance C as the opposite. Okay. So this where we say as a parallel. Okay. So when they say series and parallel, one they highlighted series parallel. Okay, and one more they highlighted based on series and parallel. It means the series part, the way they connected the capacitance will be combined with the parallel connection. Okay, so later on you can have a circuit diagram, or you can have the schematic, which you can find the series and parallel are connected. Okay, maybe you have a slightly a complicated circuit, not complicated, where you have the connections between the series and parallel. Okay, example, we have the parallel. Okay, this one I show you in terms of the parallel. Okay, then suddenly you have a connection with the series. So you have two capacitor connected in terms of the series. Then they connected with the parallel. So at this part, you can see these two capacitors connected series, but other capacitors are connected parallelly. Okay, so that's the one they say series parallel combinations. Okay, let's go with the next slides here. Okay, so let's have a look on this part here. Okay, capacitance is an element consists of two conducting surface separated by a layer of insulator medium called dielectric. Okay, so I will go through first based on the point that we have in the slides. Okay, so the second one, dielectric, is a shape according to the conductivity layers comes in different shape. Okay, what they mean with the dielectric, so I will explain to you in the later. And the purpose of the capacitor. Okay, take note what they mean with the purpose. At the same time, the definition of the capacitor and how is it works. So most of the thing is related to the stored electrical energy by electrostatic stress in a dielectric. Okay, what they mean with the dielectric, what they mean with the consists of two conducting surface. Suddenly they say the word surface here, right? Okay, let's see if they have a diagram. And they said a capacitance is an element consists of two conducting surface. Means first of the thing you need to know the shapes of the surface. You need to know the shape of capacitance. How is it look like? Okay, so that's the one you need to know. Okay, so example. Let's see, Miss can show you in the slide and not the examples here. Okay, so just have a look on this part. Okay, so just now in your the slides they highlighted to you a two layer or two surface. So it means you're going to have a first surface. So example, you just think this, you have the first surface. Okay, and the second one is the second surface. Okay, it means the second layer, and these layers are built out from a different type of materials. Okay, between the first layer and second layer you will have dielectric. So this is the one they say as a dielectric. Okay, just have a look on the pictures first. Okay, so this is the one between the two layers. Okay, they call dielectric, and the first layer as a they refer to a plates, and the second layer also they call as a plate. Okay, so just go back to your slide just now. Okay, so just have a look at this part. They say two conducting surface. So it means you're going to have the first layer, okay, and where they call as a plate. Okay, so sometimes they're using the word of the plate, sometimes they're using the word of the conducting surface. The same thing, okay, and where they say separated by the layers of insulating medium. So it means just now you can see the one I showed you in the blue color just now between the two plates here. Okay, example, this one is the dielectric. I just put as a dielectric. Okay, and the next one, you can see they have one more plate here actually. Okay, sorry for the bad drawing here. Okay, so this means this is the second layer. Okay, it means this is the second layer, or we say one of the surface conductivity, surface here. All right, and we call material. Okay, we're not sure what type of material they're using it, but we just specify as a material. Same goes to the next one. Beside the material, we also stated as a plate. Okay, and same goes to the top one. This I call as the top one. This I call as a bottom. Okay, so the top one we call as a conducting surface, or we also say as a plate. We also can say as a layer, the first layer of the material. Okay, so between this part, between the first plate here, okay, example I define as a plate. Okay, this is the first plate. Okay, and the second layer, or we call as a second plate. Between these two plates, you have dielectric. So what they mean with the dielectric? So you may have a look here. They say separated by a layer. So you can say this dielectric is as a layer, okay, or the materials between the two plates, okay, and where we call as the insulating. So what they mean with the insulating? Take note in a when they say a basic part for your semiconductor conductor or insulator. These are the three common things that you need to know. Semiconductor, excuse me, semiconductor, conductor or insulator. So the word they're using here, dielectric, as an insulating material, or we call as an insulating medium, right? So it means it's not going to conduct a current flow between these two layers. Unless you have a supply, then you will have a layer current flow from this top layer to the second layer. So this is the one they call as a middle layer between insulating medium called dielectric. This one, this part. Okay, so usually when they say capacitance, take note, you have two plate and between the two plate you have dielectric. So that's the one they mentioned for you, the point number 1. Okay, and the second part here, dielectric. Okay, take note, dielectric is shaped according to the conductivity layer. So it means it's referred to the plate number 1 and refer to plate number 2. Okay, the one I shows you, the one Miss draw right now is based on the square shape, okay, rectangular shape. Not necessarily every time your material will come out with a square shape. Okay, maybe they, example, when we see any different material, okay, they want to arrange a different shape. Example, we go on with a circle. Take note, it's just for your extra information and you need to know. Okay, so example, this is square. We also can have a circle type. Okay, we also can try to trick you by using a circle shape. Okay, so between plate number 1, plate number 2, so it's mean your dielectric also will follow the exact shape of your plates. If circle, of course your dielectric also will be in the circle form. Okay, just take note, because when we come out with the plates, okay, when I say plate, square, easy for us to calculate the area. Okay, when it's come to your circle form, you need to know the formula how you calculate for the circle. Okay, sometimes they can give you the value of diameter, sometimes they can give you the value of radius. So that's the things that you need to know for number 2. The shape can be changed, right? So the third one is just the purpose of the capacitance. So this is the one Miss highlighted to you, a store electrical energy. This is a key point. No matter any question, example, later on I give you a tutorial. Okay, when Miss asks you the function of capacitor, or I say what the definition of the capacitor, this is the key point that you need to know. Okay, so let's go for the next part here. Okay, in the next part, they just show to you the type of semiconductor. Okay, so you may have a look here. They have a few pictures here, and just have a look on this picture right now. Okay, and where they call as a ceramic capacitor. This is the one I let you know. Okay, and the same time we have this one we call as a semiconductor. Sometimes they also call as a electrolytic capacitor. Okay, but usually, basically, we always say as a semiconductor capacitor. Okay, because this is where we build up based on the mature semiconductor. Okay, and just have a look on this part. Okay, they also have a figure here. Just have a look. Okay, sometimes when you open any device, electronic devices, okay, means not ask you to open. Okay, maybe you can try to Google. Okay, usually when you're using a TV control or even though any devices, okay, control devices, okay, so when you open, you can see a PCB. So what I mean with the PCB means this one, we call as a printed circuit board. Okay, we call as a PCB, printed circuit board. So when you open your electronic devices, you always can see the green board. You always see a green board. Okay, sometimes it's very rare for us to see a different color of the board. Okay, and that's the reason why they always use it. Why they using a green color board? Why we cannot have the pink color board? Why we cannot have the purple color? So therefore always have the reason why they're using a green color. Those are interested, you can try and Google and see why they're using a PCB always with the green color. Okay, but that's not my question right now. Okay, so you just have a look on the part how they the way they have a capacitor, right, at different shapes of capacitor. So this is one of the shape of capacitor, how they put it, okay, or they placed it in the PCB. And I just have a look on the next figure. It is not exactly the same, but slightly same. Okay, so you can see based on this part here, based on the capacitance, how they have, and this each of the part terminals here, okay, they having using a soldering of flux, okay, onto the PCB. Okay, but you just have a look, okay, for your part here, you just have a look on the shapes of the capacitor. That's enough. Okay, so ceramic means you need to know the shape of capacitor will be in this form. Okay, and always have a 2 terminal. Okay, and the same goes to your semiconductor. We always have this kind of the shape of semiconductor capacitance. Okay, now okay, just have a look on the bottom circuit here. Okay, sorry, the bottom figure here. So in this figure, you can see the same thing, but this we can see in terms of components. This we call as a component, but suddenly when we go for the bottom part here, excuse me, okay, bottom part here where they call as a metal insulator, metal capacitor. Take note. And also the next one they call as a metal oxide, metal capacitor. Okay, capacitor inside a chip. Okay, what the difference? Maybe some of you ask me, what the difference between this one, and this one? Okay, let me explain to you. When they say a capacitor, they have one type we have in terms of components. This is the one I call as a component. Take note, sometimes they say as a component, sometimes they call the word element. Okay, when it's come to this diagram, when they shows you this diagram, okay, this diagram we also can say as a cross section. We highlighted as a cross section diagram. Okay, usually when you study to the higher level, then you will understand more better based on this cross section diagram. Okay, so why we need to have this kind of the diagram? Okay, when we want to have this kind of diagram, it means the capacitance that we designed it will be in the chip. So what they mean with the chip? Okay, sometimes they're using the word IC. Okay, not your identical card. This is based on integrated circuit. Okay, and at the same time they also say as a chip. Okay, the word chip. So what they mean with the IC, okay, integrated circuit or the chip, they always come out with a black box. Okay, I just say as a black box, and they have the terminal, how many terminals they have. So this is the one we call as a chip. Okay, take note, this is the one we call as a chip. All right, so inside the chip, we need to build up a components. Okay, we need to build up all the matches for the capacitance. This one is a component. We're not going to paste it. We're not going to have this component in the IC. So that's the reason we come up with a cross section we build up based on the material. All the things that you can see, example, they put as electrode 2, electrode 1, they put as a top layer, they put as a bottom layer, they put as a layer, the electric layer. So all the things here that you can see is based on the material. Okay, and once they build up based on the design, based on the simulation design, they will fabricate into a IC. All the things that you can see right now, everything they will be designed it, and after that they will fabricate it into a chip. This is the one we call as a IC. Okay, just give me 1 minute, maybe I can show you. Okay. Okay, so just have a look right now. Just have a look on my screen right now. Those not focusing, just focusing right now. Okay, this is the one I call as a chip. At the same time, we call it as an integrated circuit. So the one they build out based on the material, everything will be inside the chip. So this is the one. This is the one Miss point out as a chip. But each of the chip, they have their own code. Okay, they have their own functions. So you can see the one in the silver line. Okay, example. I view this one. Just have a look. So each of the part here, okay, the terminals here, okay, they have the reasons why they have this leg, why they have this leg. So each of the leg, they have their own function. Okay, so this is the one Miss want to specific for you now. All right, okay, let's go back to our slides. Okay. All right, okay. And each chip they have in the scale where they build up the design based on the micrometer. So you may have a look, the one they highlighted to you based on the micrometer. Okay, micrometer means is -6. Okay, but now we have downsizing the design into a nanometer. It means nm. So those still remember the unit for n. So they will need to know the n is how much. Is it -9? Is it -12? Okay, so it means the design right now, okay, nowadays they're going to be a downsizing to more smaller sizes. Okay, so that's all about this part. Okay, so let's go for the next one. Okay, let's have a look in capacitance. Okay, what they mean with the capacitance? Okay, so they have a difference between capacitor with the capacitance. Okay, so Capacitance is a property, okay, to the stored electricity. Okay, so the next one, capacitance of a capacitor. Capacitor means is a component, okay, where they're going to define based on the capacitance. Okay, take note the word here, capacitance is the capacitor. Okay, defined the amount of the charge required to create the unit potential differences. So take note the word they highlighted to you, create a unit potential differences between the plates. It means the first plate with the second plate. And the equation they're going to use to calculate the capacitance. Have a look. It's not to measure the value of capacitor, but they're going to see how much the value of capacitance. So when they highlighted to you the word capacitance, you need to use or you need to apply this formula. So it's where charge divided by the potential differences. So indirectly, either you like or you don't like, okay, you must know the charge value, how much the charge value in your capacitance. Then you divide by the potential differences. It means it's related to your voltage. Then only you can find the value of the capacitance. Okay, those have your notes with you. Please write down. Those have your notes with you. Please write down. Make sure you have your own notes for your formula. Okay, but it's up to you. This is just for my suggestion to you. It's better for you to have a formula notes. Okay, so let's go. Okay. Okay, at this slide, they just let you know, okay, when I said the units that you need to know, okay, because the measurements of the capacitance or capacitor, we always use a farad, okay. So capacitance, as we know, is where the measurements is the unit where we call as a farad, right? And where they also specific based on the column per unit volt. It means they measure based on the volt too. Okay, just have a look on this formula. Okay, 1 farad they highlighted to you is 1 coulomb per volt. Okay, take note at the same time they're using 1 C per V. It means this 1 C coulomb, this is volt. Okay, so where they is specific for you 1 farad, it means 1 value of your capacitance equal to 1 coulomb per watt. So please take note about this equation because later on when you do a tutorials, you need to convert your value. Okay, it means from the farad they can ask you to convert your value to coulomb per volt. Okay, but this is some theory that you need to remember. Please take note about this one. Okay, at the same time they just give you some explanations what they mean with the 1 farad. Okay, it's where defined as a capacitance of a capacitor which is requires a charge of 1 coulomb to okay, is which is related to your potential differences per volt. Okay, and where is related to the plates, the same thing. All right, so some students they can define it based on the formula, some students they can explain based on the terms based on the formulas here. Okay, and most common thing that you need to know based on this slide, remember, take note of this one, 1 farad equal to 1 coulomb per watt. Okay, the next one, okay, have a look on the next one. Okay, before we go with the examples here, take note, this is a one more formulas they defined it for you based on the capacitance. The process of charging capacitor depends on the current and the amount of the time taken to fully charge. So it's related to the charge and also related to the time. So to define the charge, you need to know the value of the current. At the same time, you need to know the value of the time. So as I informed you in a previous class, time is always related to the second. Take note, it's not minute. Sometimes you can have the questions defined it in the minute, but you need to change into a seconds. Okay. At the same time, current value where we always measure based on the ampere. Okay, and where we want to define the value of the charge. Okay, most of the thing you will understand when you start to do a calculations. Okay, let's go. They give you some examples here. One of the examples here. Let's see. All right. Okay. This is a basic one. Okay, let's see here. Okay, the first one, let's do together. Okay, maybe since I shows you the examples here. Okay, determine the potential differences across the 4 microfarad. Take note. Okay, determine means it means you need to calculate that. You don't need to elaborate or explain or describe things here. Determine it means you're going to calculate the potential differences cross. It means you need to know how much the voltage cross. Okay, cross. okay, at the capacitor, and the capacitance value they are given to you, which is 4 microfarad. Okay, when the charge is 5 milli coulombs, this is where based on the charge. Remember your charge unit, okay, is not a capacitance unit, this is a charge unit. Take note, okay. So when you have these informations, that is very easy for you to get the answer for your potential differences. Okay, the first of the thing you need to know which equation that you need to have, okay, or you need to apply. So based on this one, just go back to your slides, the other slides. Okay, just take note about this one. Okay, so these are the same formulas that we're going to use to calculate based on your capacitor or capacitor value, where we need to have the charge, we need to have the potential differences. Okay, take note. Okay, let's go. Okay, this one. So I'm just going to write at the top here, C equal to QV. So now I want to get the value of the V. Okay, now you can play with your maths equations, how you always done for your math equations. So it means I'm going to point out V equal to the Q divided by the C. Now I'm going to substitute the value Q. So how much the value of the Q? So from here, I already identify, we already know is a 5 milli. Take note that this C is a this is a charge value. Okay, so milli, so it means 5 times 10 minus 3 divided by your capacitance value. Okay, so C means we already know is a 4 micro. So just 4 times with 10 minus 6. So once you done a mathematical calculations, you will get the answer. So usually converted your value, get 5,000, 1,250. 1,250. Okay, you will get this value. Okay, at the same time, I always say you can use with the scientific value, right? It's better to keep in the scientific value. This answer is still right, because even the slides answer they given to you 1,250 volt. But at the same time, you can convert this value into a scientific value, is where we're going to say it's a 1.25 kilowatt. Okay, those having calculator, you may calculate because this is quite simple calculations. Just substitute, then you calculate, you get the answer. Okay, most of the important things you need to know how to use or how to apply the formulas here. Okay, let's go with the second one here. Okay, in the second one, the specific, okay, how to measure. Okay, let's see. A direct current, just go on with the number 2. This is number 1. This is number 2. Okay, a direct current of 4 ampere flowed into a previously uncharged, okay, which is 200 microfarad capacitor for 3, okay, millisecond. Okay, determine the potential differences. Okay, looks like the same thing we need to apply. It means based on the equations here. Determine the potential differences between the plates here. So it means it is similar like the first one, how we did to find the potential differences, right? But at this question, they give us some key point. Okay, the first one we can say based on the current. Based on the current, it means this is current. Okay, and they also give the value 20 microfarad. So this is based on the capacitor. And the next one they given to us based on the second. It means it's based on the time. So I just highlighted here as a T. Okay, so I have the I have the T, I have the capacitance C, the value of the capacitance. So what they requested for us to calculate is a potential differences V. So I'm going to use the same equation substitute in. So let's see how I'm going to substitute the basic formulas. Okay, we have this one. C equals to Q divided by V. Okay, we modify, okay, the equations where we get V equal Q with a C. Okay, at the same time, I need to know the value of the charge because they're not specific for us the charge value. The first one, they have the charge value, but the second question, they're not highlighted for us the charge value. So from indirectly, okay, we need to find the value, the formulas for the Q. So the formulas of the Q where we always know is the time, okay, it means, sorry, the current times with the time. This one, this means I times with the t. So you need to know the value of the current, you need to know the value of the time. So now you can substitute the value, you get the Q, the charge value. So based on this one, we have 4 ampere. So 4 times with the time, which we get 3 milli. So this means 3 times minus 3. Okay, so you will get a value here. All right. So once you've done that, okay, you can substitute directly into your equations. Okay, you can substitute directly into your equation. So let's see. Okay, 4 times with 3 minus 3 divide by the value of capacitor is 20. So this is a micro, so it means 20 times 10 minus 6. Okay, not necessary you must write 10 minus 6. Okay, you can write the U shape directly. Okay, so once you settle these solutions, you must get 600 volt. Okay, can you calculate? Can anyone calculate? I just need anyone feedback to me whether you can get 600 ohm or not. You can write in your meeting chat. Use the equation and calculate. Who know your slide answers can be wrong. Okay, please check. Do you get 600 or not? Okay. Yes, Tong Cheng got the response. How about the others? Anyone? Beside Tong, they have anyone? Do anyone get different answer? 550 wood. Or did anyone get 650 wood? Okay, I think two of you give me the feedback. 600. Okay. Take note, the slide answer sometimes could be wrong. Okay, we just want to specific earlier. Okay, but just be careful. Even though you already have the answer, you double check back. Okay, so let's go with the second one. Okay, they have one more example. Okay, this example, okay, let's see the answer they given to you. Okay, okay, they have a 16 microfarad. Let me go through with the things here. 16 microfarad capacitor is charged at a constant current of 4 microampere for 2 minutes. Okay, what they ask here, calculate the final potential differences across the capacitor and the corresponding charge in a column. Okay, it means they want the unit in the columns. It means C. Okay, and the most important thing, the same thing, we need to find the voltage here. Okay, so before I show the answer, is there anyone, okay, even you already have the answer in your slides here. Okay, I just need the step. Can you do? Or you want me to show? Is it, you want to try? Can you try? Okay, I think, okay, never mind. Then let me show to you. Okay, remember, every time when you have a questions in this type based on a capacitor, resistance, or inductor, you take note based on the key point. Okay, so the first one they already highlighted to you 16 microfarad. Okay, is a capacitance. At the same time, they highlighted to you based on the current. This one is a current. Okay, you point out this is a current. At the second value they given to you is based on the 2 minute. Take note, this 2 minute, okay, it means the time. Okay, and the next one, what they ask you to do here is to calculate the potential differences. It means the V, the voltage, or we call as a volt, cross the capacitance. Okay, and where they ask you to know at the same time they ask you to specific based on the charge value. Okay, so most of the thing as usual we need to take note. Okay, let me write down here first. I equals to 4 microampere. Okay, it means minus 6. Okay, at the same time they highlighted to us time is 2 minutes. And take note, as I inform you, minute must be converted to the second. Okay, you like or don't like, you must convert the unit to the second. So 2 minutes means you want to convert to second. I think everyone here will know how to convert, right? So where we get 120 second. Yes or not? Because 1 minute equals to 60 seconds, right? Okay. I know, Miss know, everyone know about this one. Okay. So the next one, we're going to find the value of the charge, because they're not specific for us the unit of the charge, because when they ask you to use the equations based on your charge over C, we need to know the value of the charge. So in this part, you substitute the value of IT, okay, which is 10 for 4 micro. Take note, micro minus 6, okay, with your time, which is 120. Okay, so you will get a value here. So what's the value that you get here? How much is it? Is it you get 4.810 power of minus 4? After you convert it to your scientific value, do you get 480 micro? See? Yes, someone give me the answer. Thank you for the answer. So you will get minus 4. Remember, this answer I still accept. Okay, means not say it's the wrong answer. It's the right answer, but when you do any engineering calculation, they always have a look on the scientific value. So they prefer to have in a micro, nano, or mega, tera, giga. So it's better for you to convert in this unit. Okay, so you will get 480 micro C, or you will get 4.8 times 10 power of minus 4. Okay, once you get the charge, easy for us to substitute into the equation, this equation directly. So it's VQ divided by C, so it means 4.8 times power of minus 4 divided by, okay, this one, your capacitance value, 60 times with 10 minus 6. Okay, you will get the answer, which is 30 volt, should get 30 volt. Okay. Do anyone get 30 volt? Do anyone get different answer? Do anyone get 28 volt? Do anyone get 32 volt? Okay, let me be frank to you. This one is quite simple. I mean, the example we have in here is a basic one. Okay, so later on you may find a slightly complicated questions. Is where you need to have the question will be interconnect. Okay, you need to find your Q, then you need to find the T, then you need to substitute in your equation to get your V, then you need to substitute to find your C. It means your capacitance value is how much. Okay, so this one is quite direct questions. Okay, Miss can say this is very direct question. Okay. Do anyone get different answer beside 30 volt? No. Okay. How about others? Do anyone get difference value? Okay, so let's go on. Okay, I think maybe we can take a break before we start with this one. For that, I just want to give you one, just behold, just give me a few seconds here. Okay, later on, I want you to try this question. Okay, later on, just try this question. Okay, I'm not going to give you the answer because some of the, okay, in the slide you already have the answer. This one is not going to provide for you the answer. Okay, but I want you to do. Just take note this one. Okay, I hope you can write my handwriting here. Okay, a 5 microfarad capacitor is charged, okay, so that the P dot D, so you need to know what they mean with the P dot D, yeah? Okay, between its plates is 800 volt. Okay, calculate how long. Okay, calculate how long the capacitor can provide an average discharge current of 2 amp. Okay, 2 amp dot. Okay, so I just want you to try and check, okay, what's the answer will be. Okay, so I repeat back, I write let me read back, maybe my writing quite bad here. Okay, a 5 microfarad capacitor is charged so that the PD, I'm not sure, okay, you need to know once I highlighted to you the PD. Okay, what is it? The PD stand for? Okay, the PD between its place is 800 volt. Okay, calculate how long, let's repeat back, calculate how long the capacitance can provide an average discharge current for 2 milliamp. Okay, so I leave it things with you. This part here, okay, usually means we'll discuss, okay, but I want you to try first how to get the answer, what the answer will be. Okay, so the next part, before we continue with the next slides here, we take a break for a while before we continue for the next part, based on the parallel plates capacitance. Okay, we just take 10 minutes break for a while. Means we continue. Now it's 5:11. We continue around 5:16 a.m. Okay, we just take a break for a while. Okay, at 11:16 a.m. we'll continue back.